This tutorial is for section X5, Graph Solutions to One-Step Inequalities. For 8th grade, for 7th grade, this looks more like your T5 section. So previously in the other sections, you've been asked to graph inequalities and you've been asked to solve one-step inequalities. So now they're combining those two things that they've asked you to do into one problem. So they'll give you an inequality, you'll have to solve it, and then plot that solution on your number line. So the one thing I would want you to remember, and even if you have to draw it at the top of your paper in your notebook, is this little guy here. Hopefully you've committed it to memory, but if you need a reminder, it takes just a second to draw it back out. So there's two types of circles you can have when you're graphing inequalities. You can have an open circle or a closed circle. So an open circle, remember, does not include that number. So less than or greater than. A closed circle includes that number, so it would get colored in because it could be, for this example, less than or equal to 2. So if something could be equal to 2, if that's part of the solution, then you would have a closed in circle. So both the less than and equal to and the greater than and equal to get closed in circles. The other thing you need to remember is which direction you're shading in. So hopefully you can see, I tried to color them in dark enough here. So you can see this one was shaded in to the left. This one was shaded in to the right. So you have to know which direction you're shading. So if it is any kind of less than, you're shading to the left. And what I told you in a previous lesson is I like to remember less than left. So those two L's. If you're shading to the right, it's because you have a greater than. Another way that you can think of this, and this is why I like to draw the arrows, if you think about this less than symbol being kind of like that part of your arrow, that tip of your arrow, it's going to be pointing to the way that you're going to be shading, right? So you can think of that either way. You can draw your graph, you can memorize it, but you just need to know those two things in addition to how to solve inequalities. So let's look at some sample problems. What they'll be asking you to do is solve the inequality and graph the solution. So they have t plus 7 is less than 8. Remember, we're going to treat this inequality sign just like an equal sign and apply all of our rules of algebra to that. So I want t by itself on the left, and so I'll need to subtract 7 from both sides to make that happen. So 8 minus 7 is 1, so my solution to this inequality is t is less than 1. So since it's only less than, it gets an open circle at 1. And then since it's less than, I'm going to shade to the left where I can think about that inequality symbol giving me some direction as to which way my arrow would be pointing, right? So I'm going to shade in this side. If you're trying to think of examples of real life when you would think about less than versus less than or equal to, think about maybe your mom or dad giving you some money, and if they say, here's $5, you can spend all of it, it's yours, right? So you can spend less than or equal to $5. So including $5, if you spend all of it, you're not in trouble. But if your parents give you, say, like a $10 bill to go get something worth $5 and they say, bring you the change, then you can't include $10 in the amount that you're able to spend because they are expecting change. So it would only be less than a certain amount and not less than or equal to 10, right? So let's look at some more examples. Once I did this first one, I didn't write out the directions because it's going to be the same for all of these. So number 2, y plus 2 is greater than or equal to 6. To get y by itself, I'm going to subtract 2 from both sides. 6 minus 2 is 4. So my answer here is y is greater than or equal to 4. So I'm just sketching these out here, putting a number behind it and a number in front of it. When you're doing it at home, you'll have to make sure that you either do it on a laptop or turn your phone or pinch out, so you can see the whole screen, because you'll have to, on IXL, make sure that you color in the end of the arrow. So it's not good enough to just put the dot there and then color part of it. You have to put a dot, decide what color dot by tapping it again, and then go all the way to the arrow. So don't miss any points by not going all the way to the end because you can't see it on your screen. So y is greater than or equal to 4 gets a colored in bubble, and then it gets shaded to the right. Excuse me. Number 3, g divided by 2 is greater than 4. So this looks a little scarier maybe, but we can do it just by applying the same rules that we know for algebra. So if this is a division problem and a fraction represents division, how to undo division, we use the opposite operation of multiplication. So what do we choose to multiply this by? The denominator. So that'll cancel out the 2 and leave g by itself. But what we do to one side, we have to do to the other. So when I rewrote this, I put g divided by 2 in parentheses, so I know I'm multiplying that by 2. On the other side, it will be 4 times 2. That cancels out our 2 here, leaving g by itself. 4 times 2 is 8, so my answer here is g. G is greater than 8. It gets an open circle because it doesn't include 8, and then it's shaded to the right because the numbers to the right of 8 are the numbers that are greater than 8. All right, number 4. Z divided by 3 is less than 2. Just like in number 3, I'm going to multiply by the denominator, which is 3. What I do to one side, I have to do to the other. So that leaves me with z by itself on the left. And then 2 times 3 is 6. Z is less than 6 is shaded in this way to the left with an open circle at 6. Number 5. B minus 1 is greater than 8. I'm going to add 1 to both sides. 8 plus 1 is 9, leaving us with b is greater than 9. So an open circle at 9 and then shaded to the right. Number 6. 5p is less than or equal to 10. Now here we have multiplication, so the opposite of multiplication is division. So to get p by itself, I'll need to divide by 5, which will cancel this out and leave p alone on the left side. What I do to one side, remember, I need to do to the other. So 10 divided by 5 is 2. P is less than or equal to 2. So that gets a closed in circle at 2, and it's shaded to the left because the numbers to the left of 2 are the ones that are less than. Number 7. 3g is less than or equal to 9. So to undo this multiplication, because when two things are written side by side in algebra, we know that that means that they're being multiplied. So just like in 6, we're going to divide by this 3 to get rid of that 3 and leave g by itself. What we do to one side, we have to do to the other. So 9 divided by 3 is 3. So g is less than or equal to 3, gets a closed dot at 3, and is shaded to the left. 2 more sample problems for you. Number 8. S plus 9 is less than or equal to 10. We're going to subtract 9 from both sides, leaving us with s is less than or equal to 1. It gets a closed dot at 1 and then shaded to the left. And our last sample problem, 1 is greater than or equal to v plus 4. So we're going to subtract 4 from both sides, leaving us with negative 3. Negative 3 is greater than or equal to v. Now here's my trick for you. If you are seeing something like this with your variable, your letter on the right side instead of the left side, you can't just use this without thinking a little extra step here, because you'll possibly get it wrong. So what I like to do is I like to rewrite it with my variable on the left. But to get that sign right, you have to read it backwards, is what I'm going to call it. So if I were to read it backwards, I would say v is less than or equal to negative 3. So if we're reading it in that direction, that sign reads as a less than or equal to instead of as a greater than or equal to. So I like to rewrite it. You'll see in some upcoming sections it's helpful to do that so you don't graph this incorrectly. So if you don't want to write it down and you just want to look at this and say v is less than or equal to negative 3, and you can graph it that way, no problem. But if you need to rewrite it to help you, no problem at all that way either. And that's it.